All right, example 9. And I'm not going to read the function. Let's read the function. F of x is equal to 2 times x minus 3 squared times x plus 7 not squared. And then all divided by x minus 3 times x minus 2 times x plus 8. So you can probably tell we're going to have to simplify this in a little bit. Let's look at the domain. Set the denominator not equal to 0 and solve. It's in factor form like some of the other examples, so that's pretty straightforward. Not 3, not 2, not -8. These are the values we exclude from the domain. These are the values that we're going to test later with the simplified function to determine if they're a whole or a vertical asymptote. X-intercept. Set the numerator equal to 0, which is also pretty straightforward. You're only looking at the factors. 2 is a coefficient. It doesn't have an x, so it doesn't have anything to do with the intercept. So 3 or -7. 3 we excluded from the domain, so it is not an x-intercept. So only the -7 will be the x-intercept. Remember to write it as a point. Simplify the function. We're going to cancel one of the x minus 3's. Remember, we always simplify to avoid the extraneous divide by 0. If we happen to divide by 0, we know that's a vertical asymptote and not a whole. So when we evaluate with -8, you see the factor in the denominator causes us to divide by 0. And then we evaluate the simplified function with the +2. There's also a factor in the denominator that causes us to divide by 0. And then finally, the simplified function evaluated with 3. In this case, there's a factor in the numerator that creates a 0. So now we have 0 divided by 11, which is still going to be 0. So this is a hole in the graph. Remember to write the hole as a point, 3, 0. So the two values that made us divide by 0, those will be the vertical asymptotes. Always write your asymptotes as equations of lines. Next comes the y-intercept. This is when x is equal to 0. So evaluate the function x equals to 0. I always use the original just in case I made a mistake with the simplification. I'll let you do calculations on your own. 21/8. You can write it as a fraction or write it as a decimal. The decimal will be a little bit more helpful when we graph it, because I know where to put 2.6. Horizontal asymptote, compare the degrees. They are equal to each other. So our horizontal asymptote is the ratio of the leading coefficients, which is where that 2 coefficient came into place. We have a horizontal asymptote, so there's no slant asymptote. And the end behavior model is going to be y equals 2. Let's take a look at the graph. Just like before, start by plotting the intercepts and the hole and drawing dashed lines for the vertical and horizontal asymptotes. Label all of these things. Label them correctly. Don't just make up names. Alrighty, see that 2.6 was helpful because I know to put that y-intercept above that horizontal asymptote. Draw a big old circle for the hole. And now we want to consider where to draw the graph. So a little bit of logic and deduction. So on the left side of the graph, to the left of the -8, there are no x-intercepts. So I know the graph has to be above the horizontal asymptote. Now we consider in the middle, I've got to connect the dots There's only one way that I can connect those two intercepts and go to the horizontal and vertical asymptotes. And the same thing on the right. I have to connect the graph to that hole in the graph, so it has to be there. If you need to test points, you can, but this one was pretty straightforward. There was no other way to draw this. And that is the last example. So there you go.